board.
Yeah. No, it's this one. Okay.
Are you doing it after this?
Yeah. So can you see the screen?
Yep.
Okay, so this is practice set number 1. So the first problem was number 4, which is the limit is that as x goes to, you have to read it. I can't read that with my eyesight. X goes to
Infinity.
X goes to infinity. Okay. Of x squared minus 8.
No,
over,
x to the 4.
oh, x to the 4th. X to the 4th minus, I'll write it that way. X to the 4th minus 8 over 10x squared plus 25x plus 1. So when we have polynomials like this,
Really easy.
right, it's really easy. We look at the numerator and the denominator. So we can write this as the limit as x goes to infinity. We'll pull out the highest power of x. We'll have x to the 4th, and it's 1 minus 8 over x to the 4th. And then down below, we'd pull out a 10x squared, and it's 1 plus, now 25x, when we pull out a 10x squared, is going to be 25 tenths 1 over x, and the next one is going to be 1 over 10x squared. And so we want to use,
Or 5 over 2, right?
right, we want to use the limit of a product is the product of the limits. And that's okay if the limits, if at least one limit exists. So when we look at this, as x gets really, really large, what does the 1 minus 8x to the 4th go to?
0.
Nope.
1.
Yeah, this goes to 1. And what does the bottom go to? Also 1. And that's why we pull things out. So this is going to look like the limit as x goes to infinity of x to the 4th over 10x squared, which is the limit as x goes to infinity of x squared over 10, which is just going to be infinity. And so it's not that bad to handle something like this. But the next one was number 7. So number 7, what is that saying? The limit
X to 6 minus.
6 minus?
Yeah.
Okay. And then we have, wait, this is number 7?
Yeah.
Okay, so it's x plus 2. And then it's divided by x squared minus 4x minus 12.
Yeah.
So 6 minus means the following. Here's 6. And this is basically the limit as x goes to 6 from below. And we call that the limit as x goes to 6 minus. In a complete shocker,
6 plus.
yeah, what do you think 6
From above.
Yep. So if I give you the limit as x goes to 6 plus, that'd be coming from above. So why does this matter? Well, whenever you see a polynomial and you want to try to understand things, it's often not a bad idea to factor it. So this is the same as the limit as x goes to 6 minus. Well, the top is just x plus 2. How do we factor the bottom?
X minus 6, x plus 2.
Yeah, and in fact, there's a real hint that x minus 6 has to be a factor because they're giving you this problem. They're looking at what goes on as x goes to 6 minus. So almost surely x minus 6 is one of the factors. Now this is particularly nice. What do we know about the x plus 2 over the x plus 2? They cancel. So this is the same as the limit as x goes to 6 from below of 1 over x minus 6. So if we were to plot this function, here is 0, here's 6. We have a vertical asymptote at 6. As x approaches 6 from above, what does 1 over x minus 6 go to? So
Zero.
as x approaches 6 from above, so think of x as 6.1, 6.01, 6.001. What is 1 over x minus 6 going to look like? It's going to look like 1 over 0.1, 1 over 0.01, 1 over 0.001.
Let's go to infinity.
It's going to go to infinity. So the plot is going to look something like this. What about as x goes to 6 from below?
It's going to go negative.
It's going to go negative. So think of x as 6 minus 1/10, 6 minus 100, 6 minus 1,000.
Yeah.
As x goes to infinity, what does 1 over x minus 6 go to?
0.
0. And same thing. So so it's going to look something like this. And so the answer for this problem is it's going to go to
Minus.
negative infinity. Okay, the next one was number 9. And this is the limit as x goes to what term?
7 plus
X goes to 7 plus
of x over absolute value of x.
x over absolute value of x. So when we look at x over absolute value of x, this is number 9, and it's x goes to not 7
Oh,
plus,
it's
it's
0.
0 plus.
I was looking at this one.
Yeah.
Sorry.
So what can you tell me about x over x plus? So if x equals 0, it's undefined, right?
Yeah.
If x is greater than 0, it is what?
1.
1. If x is less than 0,
Negative.
it is negative 1. So when we have this, the plot looks like the following. Here's 0. It's going to be open circle at 1 and open circle at negative 1. So what's the limit as x goes to 0 from above?
1.
It's just going to be 1. And if I gave you the limit as x goes to 0 from below, it'd be minus 1. Number 12.
Yeah.
12, we have f of x is x squared minus 5 if x is less than or equal to 3, and x plus 2 if x is greater than 3. And we want to find the limit as x goes to what number?
3 minus
3 minus 3 plus
and
3. So we say f is continuous at a if the limit as x goes to a of f of x equals f of a. So that's what it means for function.
Steve. Oh,
Yep.
never mind.
Okay.
It was frozen, but now it's better.
Okay, good. So we say a function is continuous at a point if the limit as x goes to that point of f of x equals f of a. So here, why is 3 the interesting point to look at?
Because that's where equal. There's like a gap.
Well, not necessarily a gap. We have a split
Yeah.
definition.
Sure.
So split definition. So x equals 3 is interesting. Right? So now let's look at the limit as x goes to 3 from above of f of x. Well, if x is greater than 3, which definition do we use?
The bottom.
So that's just going to be the limit as x goes to 3 from above of x plus 2. And what will that equal?
5.
5. And if we look at the limit as x goes to 3 from below of f of x, that's just going to be the limit as x goes to 3 from below of x squared minus 5. What will that equal?
4.
4. So is the function continuous or not?
No.
So as different, f is not continuous
They're both like 4
At
plus
a-
5. It would be,
exactly at x equals 3. And so then the question is, what is the value of f at 3?
4.
Yeah, f of 3 equals 4, as the definition is for x less than or equal to 3. Okay, so number 15. So what's number 15? So find the limit as x goes to what?
0.
0 of x over cosine of
No,
x?
3x. 3
Oh,
times
three times.
x over cosine of x.
Okay. So this is a little tricky. So do we agree that this is 3 times the limit as x goes to 0 of x over cosine of x? That we can
Yeah.
just pull out the 3.
Yeah.
Now, we want to use the limit of a quotient. Suppose the quotient of the limits. What do we have to be careful about the denominator?
Oh, when cosine is 0.
Right, need denominator not to be 0. Is the denominator going to be 0 as x goes to 0?
Yeah. No.
What is cosine of 0?
0. Right?
What's cosine of 0?
Oh, 1.
It's 1.
Sorry, I was saying
Yep.
of 90.
So this is going to be 3 times the limit as x goes to 0. And see how I'm showing all the steps of x divided by the limit as x goes to 0 of cosine of x. So it's going to be 3 times 0 over 1, which is just 0. Okay, now 2 more for this section. So now we have number 19, which is the limit as x goes to what?
Infinity.
Infinity. This is an interesting one, sine of 1 over x. So this one is a bit hard. So the question is, what happens as x gets larger and larger and larger?
Sine of x, 1 over x goes to 0.
So as x goes to infinity, 1 over x goes to what?
0.
Goes to 0. So this looks like the sine of 0. And what's the sine of 0?
0.
It's just 0.
So that's it.
So it's just 0. So let me give you a harder one. This would be number 19 plus. Let's look at the limit.
So from above.
Making it a little harder. The limit as x goes to 0 of the sine of 1 over x. What do you think is going
Isn't
to
that what
happen
it
here?
is? Oh, no. it's
Now
0.
x is going to go to 0. So what does 1 over x go to?
Undefined.
So 1 over x goes to what?
0.
Well, as x goes to 0, what does 1 over x go
Oh,
to?
1.
Why 1?
Oh, well, no, it doesn't. But
As x goes to 0, what does 1 over x go to?
infinity.
Goes to infinity. So do we think the sine of 1 over x converges to a number, or do we think it oscillates?
Uh,
No. Remember what our plot of sine looks like. Sine looks like this and keeps repeating periodically, right? As we go off to infinity, do you expect that this is going to converge to something?
No.
No. So let's take x. Give me a value of sine that's going to be 1.
Pi half.
Okay, give me another value.
3 pi 4. Halves, sorry. 3 pi halves.
Well, 3 pi halves is not going to give you 1. So if
No, it's going to give me a lot less.
so,
Yeah.
So the sine of u equals 1 if u equals pi halves. What's the next value where we get a sine of 1? It might not be between 0 and 2 pi.
Oh.
You have to go around again.
Oh.
So it would be pi halves plus what?
2 pi.
2 pi. And then pi halves plus 4 pi. Pi halves plus 6 pi. And so on and so on and so on. So if we take xn equal, so I take 1 over xn to equal pi halves plus 2 pi n. Okay.
Yeah.
Then this is the same as saying we're taking xn to be 1 over pi halves plus 2 pi n. What does pi halves plus 2 pi n go to as n goes to infinity? As n gets really, really large, what does pi halves plus 2 pi n go to?
Infinity? No.
Cool.
Wait, what was it?
So what is the denominator pi halves plus 2 pi n go to as n goes to infinity? The denominator just goes to,
And
well, as n gets larger and larger and larger, what does pi halves plus 2 pi n go to?
2 pi n
No,
infinity.
which is it?
Infinity.
Infinity. What do you think?
Well, I said infinity first, and like you said
Okay.
no.
All right, we can check the audio later.
Well,
Do you agree that the denominator goes to infinity? Mr. S, are you there? So what we were doing is we were looking at the limit as x goes to 0 of the sine of 1 over x. And so we were letting x go to 0. So as x goes to 0, 1 over x is going to infinity. So if you look at the plot on the right, you can see that this is, a plot of what the sine function looks like. And you can see that it's oscillating and that it's repeating. And so that as we go, further and further down, oops, still in the race mode. As you go further and further down, you're just going to get more and more copies of it. And so if we want to look at what happens as 1 over x goes to infinity, or equivalently as x goes to 0, we don't expect the limit to exist. And so we came up with an explicit sequence. And we said, for instance, let's take all the values that have a sine of 1. So the first one that has a sine of 1 is pi halves. Then pi halves plus 2 pi, pi halves plus 4 pi, pi halves plus 6 pi, and so on. And so if we take 1 over xn to be pi halves plus 2 pi n, or equivalently xn equals 1 over pi halves plus 2 pi n, then we get that the sine of 1 over xn is the sine of pi halves plus 2 pi n equals 1. And similarly, if I want to get minus 1, I should look at, what should I look at for minus 1?
3 pi halves.
So it should be the sine of 1. So I would want what? 3 halves pi plus 2 pi n equals minus 1. So we see that here the limit does not exist. So limit does not exist. Okay.
So that's probably
Yeah. So the last
That's
problem, no, we can do both sections. So the last problem from this section is 20, which is the hard one. So we have the limit that as x goes to 0.
Yeah.
Of sine squared of 7x over sine squared of 11x. And so one way to start this problem is to say that this is the same as the limit as x goes to 0 of the sine of 7x over the sine of 11x squared, right?
Yeah.
That just makes things a little simpler. So this is the same as the limit as x goes to 0 of the sine of 7x over the sine of 11x squared. So we need the limit as x goes to 0 of the sine of 7x over the sine of 11x. Now as x goes to 0, what does the top go to?
0.
And what does the bottom go to?
0.
So as it's 0 over 0, we can use, do you remember L'Hopital's rule?
No. That 0 over 0 is 0.
No. So this is that
Oh, I think I do actually
limit
remember it.
as x goes to a of f of x over g of x is 0 over 0 or infinity over infinity.
Take the derivative
Yep,
until it's not.
right. It's the same as the limit as x goes to a of f prime of x over g prime of x. So this is one of the most useful rules. And the proof was if we look at the limit as x goes to a of f of x over g of x, this allows us to review a lot of the great concepts. We can subtract f of a and g of a. So we'll assume we're in the case where f of a equals g of a equals 0. So we can just subtract f of a and g of a, right? Why can we just subtract f of a and g of a?
It's like adding 0.
Yeah, because it's adding 0. If we subtract 0, does that change anything?
No.
No. And now I could also divide both sides, the numerator and denominator, by x minus a. And because I divide the numerator and the denominator by the same thing, it doesn't change anything. But what is the top? This is our definition of the derivative.
Yeah.
So by the definition of the derivative, we have f prime of a is the limit as x goes to a of f of x minus f of a over x minus a, or the limit as h goes to 0 of f of a plus h minus f of a over h. And so this is going to become f prime of a over g prime of a.
Yeah.
And if we have 0 over 0, we just do it again. So now what we can do is going back to number 20. Wish I knew how I moved back a page. Okay.
It did move back a
I
page.
know. So number 20 continued. We need the limit as x goes to 0 of the sine of 7x over the sine of 11x. So as we have 0 over 0, we can use L'Hopital. And you've made it when your name becomes a verb. So what is the limit going to be? What's the derivative of sine of 7x?
Cosine 7.
Be very
Wait.
careful how you do it. The derivatives, what rule are we going to use to take the derivative of the sine of 7x? So if a of x is the sine of 7x, what rule is this?
Chain.
Chain. So a prime of x is going to be sine prime at 7 of x times the derivative of 7x.
So square 7.
Okay. So what is the derivative of sine of 7x?
Cosine 7 x.
Mhm.
And then times 7.
Times 7. And what's the denominator? Cosine 11x.
Times 11.
And now what does the numerator go to as x goes to 0?
1.
So this is going to just
Or
be
7.
7 elevenths.
Yeah.
So original problem is going to be 7 elevenths squared. Okay. So any questions on how to do problems like this? Okay, we all good on these? So these are the basic limit calculations. And so if you can do stuff like this, for the most part, you're going to be fine. All right. So the next one was, this is, what page is this?
110.
So page 110, this is practice set 2. And so we've got 4 problems. So the first problem, number 1, is the function, we give you the function f of x. Can you read the 3 parts? It's
Which one?
first, for number 1. It's x plus 7.
Yeah.
If x is less than or equal to 2.
Yeah.
Is it less than or equal to, or just
No,
less
just
than?
less than.
Okay.
Sorry.
So I like to write if x is less than 2. What's the next one?
9.
9.
If x is 2.
If x equals 2, and then
3x plus 3.
if,
X is greater than.
so the question is this function continuous?
No.
What's the one point that's going to be difficult? Where's the one danger point?
2.
Right. The danger point is x equals 2. It's clearly continuous elsewhere.
Yeah.
So as x goes to 2 from below, the limit as x goes to 2 from below of f of x is going to be what?
9.
9. What is f of 2 equal to?
9.
9, which is good. but the limit as x goes to 2 from above
It's not
of f
9.
of x is equal to
The
limit
12
as x goes to 2 from above of 3x plus 3
is 12,
is y is it 12?
right? Oh wait, no, sorry. Oh, not 12. I was thinking if x was 3. It's also 9.
It's also 9.
So it does.
So is it continuous?
Yes.
So continuous as all 3 are 9. So that's problem number 1.
Which is pretty simple.
Yep. So problem number 3. What's number 3? Can you read it?
Is the f of x equals secant of x continuous everywhere?
Is this continuous everywhere?
No.
So the first thing is, whenever I see a function like secant, I always rewrite it. It's 1 over cosine of x. So as soon as you see a division, what's the danger?
When cosine of x is 0.
Danger when denominator is 0. Cosine of x equals 0 when x equals what?
1 or 2 pi. Wait, no. Yeah. No. Pi over 2.
Just
Sorry.
making sure everybody's still with us. Okay. So when is the first time cosine of x is 0?
Pi over 2.
Pi over 2. When else?
3 pi over 2.
3 pi over 2. And then pi over 2 plus 2 pi. 3 pi over 2 plus 2 pi. Pi over 2 plus 4 pi, and so
Okay.
on. So is it? So these are all the points where it's not continuous.
See.
So not continuous here, okay, elsewhere. Right. Any questions in Zoom land?
No.
Okay, so next one is number 5. And so again, what I really want you to see is just how many steps I'm putting in and just how carefully I'm writing all this up. So 5 is the function
F of x equals secant of x. Continuous on the interval minus pi halves, pi halves.
and now this is important. So this is some notation. So we have parentheses. So parentheses means do not include point. So parentheses AB means A is less than X is less than B. Brackets mean include points. So if I give you bracket
Yeah.
AB, that
Less than or
means
equal to.
A
greater
less
than,
equal to
yeah.
X, less equal to B.
Yeah, I've seen that before tons of times.
And what if I give you parentheses AB bracket?
We did this earlier in pre-calc.
Oh, good.
That'd be,
Just make sure it's
yeah. That'd be A is less than X, which is less than or equal to B.
Yep. So for this function, is it continuous on minus pi halves to pi halves?
No. Yeah.
Yes. Continuous as no place
Like
here
home.
where cosine x is 0. Because our function is just 1 over cosine x.
Yeah.
So the function will be continuous. So the key part here is the notation. So this is extremely valuable notation. Now, there are some mathematicians who use different notation than this. They use inverted parentheses, but we will ignore that notation. Right. And that was number 5. So the next is number 7. Number 6. What's number 6?
For what values of k
Okay.
is the function f of x
So
equal
give me the top. The top is 3.
x squared minus 11x minus 4.
And
X is less than or equal to 4.
okay.
Continuous at
And
x
what's the
equals
other one?
4,
What's the other one?
kx squared.
It's what's the bottom? It's,
Kx squared
okay, kx squared.
minus 2x minus 1, x is greater than 4.
X is greater than 4.
Yeah.
Okay, so
And we need k, the value for k to make this continuous.
right, so we need the limit as x goes from 4 below of f of x to equal f of 4 to equal the limit as x goes to 4 from above.
So
of
we
f of
pretty
x.
much, yeah, so we need these to be equal.
Right. But we're actually lucky because the top is defined for x less than or equal to 4, so we have no problem.
Yeah.
So what does this left-hand side equal? As x goes to 4 from below, or f,
I think it equals 0.
so we'd get 3 times 4 squared minus 11 times 4 minus 4. So this is 3 times 4 squared. Now this is minus 12 times 4, right?
Yeah.
Well, 12 times 4 is 3 times 4. 3 times 4 squared minus 3 times 4 squared. And so it's 0. So without actually multiplying anything out,
I knew it.
it's 0. So we need, so what is this limit? It's going to be k times 4 squared minus 2 times 4 minus 1.
We can move like the 2 times 4 minus
So
1
this
to the other
becomes
side.
16k minus 8 minus 1, right?
Yeah, so 9/16.
And what do we want this to be? So this is 16k minus 9.
Yeah, and we want that to be 0.
So need
Equals 0.
16k minus 9 equals 0.
Basic
So
algebra.
k equals 9/16.
Yep.
Okay. And then the last one,
At what point is the removable discontinuity for the function f of x equal x squared plus 5x minus 24 over x squared minus x minus 6 question mark?
so we want to know at what point is the discontinuity removable?
We
Where
should simplify.
is the discontinuity? And so what's going on over here is
When
when you,
simplify it,
well,
like-
exactly.
minus 3 and 8 to the top and
So
minus 3 and 2 for the bottom.
so the top is x minus 3, x plus 8, and the bottom,
x minus 3, x plus 2.
and so initially we have concern if the denominator is 0. So we worry about x equals 3 and x equals negative
Wait,
2.
what does discontinuity mean again?
So discontinuity means it's not continuous.
Okay.
So basically things, if the function blows up, it's not continuous.
And it does blow up, right? I
So,
like
so where
minus
does this
2,
function blow up?
minus 2 and 3.
But does it really blow up at 3?
No,
Why not?
isn't there like a hole there?
Well, if you look at the definition,
Is that?
this is the same as x plus 8
Oh, I'm
over
thinking of the
x
graph.
plus 2 if x is not 3.
Yeah.
Right?
So there'd be like a hole at 3.
So when we're looking at what's going on,
There's just a hole.
there's a whole, but it
But
gives
it's
us
on
an,
the graph.
it gives
Yeah.
us an idea of how we should define it. So we remove the x minus 3 in the numerator and denominator. And what would f of 3 equal now?
Oh.
Zoomland? It'd be, I'm sorry?
11/3.
Yeah, that would be 11/3. And so we now have a way, this is called removable because really we haven't changed the value of the
Wait.
function anywhere except at the point
Wait, how is it 11/3?
when we take x equals 3.
Yeah.
Oh, it's not 11/3. I might have misheard you. It's 11 what?
Fifths. I did say 11/3, but
Okay. Okay.
It's like,
Yep. And so when we look at this, initially the function wasn't defined at x equals 3, but
yeah,
when we
so
look
you'd
at it
have
more
a hole at
closely,
11.
right. So this is the first set of problems. So if you guys are comfortable with this, it means I think you're really good on the first 2 sections of the AP